Good morning, students. In this video, I'm going to explain how to implement the binary tree concept using C language. So the binary tree, what is the binary tree? The binary tree means no node can have more than two children. That means if the node has 0 children, 1 children, and 2 children, it's called as a binary tree. And the values are filled from the left to right. That's the concept of binary tree, right? So how to implement with help of the C language, I'm going to explain here. So first of all, this is the implementation of binary tree. I'm going to add the header files here. Include stdio.h, then include stdlib.h. This is for input output, and this is for I'm going to use the linked list concept. So that's why we need to add this header file here. Then it is a linked list representation. So I'm going to create the structure concept. Struct. Then name of the node is binary tree. Binary. Okay. Under this, what other field should be the node have? It is the data part, left child and right child, right? So integer, data, then left child, it should be one of the pointer. So you have to create that pointer as a self-referential pointer. So you have to give like this, struct binary asterisk left. Okay. Then likewise, we need the right child. So it is also self-referential pointer. So binary asterisk right. This all we already discussed in the class, right? So I declare the elements of the node, okay? One node should have the data part, the left child as well as the right child, okay? Then I'm going to write the main function, okay? So here I'm going to use two functions, operations. I'm going to create. Also, I'm going to display the values, what I have created, okay? So I have introduced the function, what I'm going to use to the compiler. So that function name is actually create, okay? So here what I'm going to do, under the create function, what is the data type of this create, right? So this create is going to display one node. So it should be what? The structure data type. So self-reference structure data type. So I can give like the data type of this function is struct struct binary asterisk. Okay, so that means the function which one I'm going to use the create, the return type of this function is what? The tree. So the tree should have the data part, the left child and the right child. So that's why I have declare the data return type of this function is structure. Okay. Then one more function I'm going to use that is in order. Okay. So in order ORDR. So here I'm going to display return. Okay. What I'm going to return is one tree I'm going to return. So here I can use again the struct binary asterisk. But this function doesn't return anything. So I can give this as a void. Okay. So these two functions I'm going to use our program. That's why I have introduced to the compiler, right? Then for creating the tree, we need a root, right? So that means I'm going to create one object, pointer object. It is also self-referential pointer. Struct binary is a root. Okay, I have given the name like root. And initially I have assigned the root equal to null or 0. I'm going to assign like this. And I'm going to call the function create. Okay, the create function I'm going to call. And the function, what the create function going to return, that I can store to the root. Okay, for example, root equal to create. That means one create functions declare, right? So I'm going to call the create function. That create function is going to return one tree that no, I'm going to store in the root variable. Okay, because root is what? It is the object of the structure. So it should have these three fields. Okay, so now I'm going to write the create function. So first of all, what is the return type of this? What is the return type? Struct, binary, asterisk, create, right? Here, I'm going to create a node here. So one more object I'm going to use. Struct, binary, asterisk, new node, right? Then I'm going to allocate the memory for this new node, right? So that's why we need the malloc. New node equal to, first you have to write the return type of this new node. So what is the return type of this new node? Struct, binary, asterisk, malloc, size of what based on the structure type. So struct, binary, right? So that time the memory is allotted. Then after that, what happened? I'm going to allocate one x variable, that is integer x. With the help of this, I'm going to read the value, okay? So here, I'll give the message printf, enter the value. If -1, the value is null, like we have given, okay? So here I'm going to check if x equal to -1. That means it's going to return 0. Return 0. Else, that value I'm going to store into the data, right? So before that, we need to read the value, right? What is the x we need to read? So that's why we have to use scanf. Scanf %d. Address of x. Okay. So now I'm checking. If x equal to -1, you can do that. Otherwise, new node when I create a node, that is new node tends to data part, right? So data part is there, right? Data equal to n. Good. Next, so print of enter the right child value. Sorry, left child, because we need to fill the data from the left to right. Left child value. So here I'm going to use the recursive function. Okay. So new node tends to my left equal to, again, I'm going to call the create function. Yes. So one node be created. There is a root node. Then what the value I'm going to read, the value is other than -1, I can store in that node. After that, the next data where you can keep it is the left child. So enter the left child value. Okay. And where you can enter this left child value, it should be the left of that node. So again, I'm going to call this function. So it can read x, then it will check if it is -1, 0, otherwise that left child is going to store. Okay, that is the concept. Recursive function we are using here. Okay, likewise, we need to call, enter the right child value. So there you can store new node tends to write equal to create. C-R-U-A-T. We call the function. Okay. After that, return this new node I'm going to return. Okay. Once it is returned, this new node values store in the here. It will return here, right? So now root have the new node value. Then what we need to display that. That's why we can use the function in order. So I'm going to call the function that is in order of what? This is the root. This root I'm going to assign. Okay, I'm just call. So I'm going to explain about that. The return type of in order is void. Then in order equal to what is the argument type? What's the function root I'm going to pass? What is the root? It is a node, right? So again, I have to give struct binary asterisk, right? So in order means what? How to display that? If it is the binary, what I'm going to return? Root, right? Root I'm going to return here. Binary asterisk. Then here, I'm going to check if root equal to null, it does not return anything. Okay, so that is return null. Otherwise, again, it is the recursive function in order of what should be that root now? Root tends to left. Okay. Then printf, I'm going to display the value. Printf %d class t, comma, root tends to data. Okay. Then in order, what we need to call? We need to call the write. So root tends to write. Right? That's all. Small. Okay. So this is in order. Okay, let me check the program. I'm going to run. The capital S I have given here. So small s. Yeah, here I didn't give where is the scanf. Yeah. Under the value. Okay, minus if -1, the value is null. So I'm going to do the 34. Under the left child value, I'm going to give initially -1. We need to check what has happened. Yeah, that's the right child value. So again, I'm going to give -1. Yes, only one node is there, right? So that's why it is written 34. So if again I'm going to explain under the value, so 34, then under the left child value, again I'm going to give 10. This left child value, I'm going to give the -1, okay? Then it's asked the right child of that value, that I'm going to give 24. The left child, for that node, it's also left child. I'm going to give like -1. Then that node right child value, I'm going to give -1. Again, -1. See, uh, 10, 24, 34. Left child, right child, and the root value it is going to print. Yes. Thank you, students. I hope you can understand how to execute this code, how to implement the binary tree concept.